Lesson 5.4. In 5.4, if you notice the topic, it's called the Pythagorean theorem, which you guys have all done before, but it also says in its applications. So there is a little bit more, but the Pythagorean theorem should hopefully be a review for you. The Pythagorean theorem, I hope everybody remembers, only works in a right triangle. So if it's not a right triangle, it's not going to work. But then what you would do is you would do a squared plus b squared is equal to c squared. And again, if you remember this from algebra, because it's in the algebra book, the a and the b are the two legs and the c is the hypotenuse, okay? One of the twists on today's lesson is that you have to leave your answers in radical form. So basically what this is saying to you is no decimals. So that might be a little bit different than what you did in algebra class. And you're going to use this in the next two lessons. So even though normally these have been very independent lessons, 5.5 and 5.6 actually do have a little bit in common, okay? So when I look at this, here's going to be like, say, my A, and here's my B, and then here's my C. So I just plug it in. A squared, B squared, C squared. So that's 4 and 36. That's 40. Now you have to take the square root. And if you grab your calculator and you try to do it, if you type in the square root of 40, you're going to get a decimal. Well, we're not allowed to have decimals, so we have to break the 40 down. I like to use the multiple method, so when I think of 40, I think of 4 times 10. So the square root of 4 is 2, and the square root of 10 can't really do much with, and so there's my answer. So 2 square roots of 10. So why don't you go ahead and pause it here and try the other three, seeing how, again, you should have done a lot of this in algebra, so it shouldn't be too new. So go ahead and try them. All right, hopefully you've tried them. And let me write down the answers, and if you got them right, then you can obviously fast forward on to the next part. So the correct answer for this one would have been 4 square roots of 5. This one actually just came out to be the square root of 39. There's not really much you can do with that one. And then this one either came out to be, if you want to look at it, as the 25 because it says radicals, but this is perfect, so probably most people would be okay with if you just turned it into 5, even though there's no radical left. So if you got that correct, go ahead and move on to 5. If you didn't get it correct, let's go through it together. We have a squared, b squared, c squared. So we're going to go 4 squared, 8 squared, x squared. So that's 16 and 64. So it's what, 80? And now we'd have to take the square root. So the square root of 80, if we break it down, a lot of people might like to use 4 and 20 on that. Here's the problem with 4 and 20. If you take the square root, 4 is perfect. Then you got to do 20, because 20 is made up of 4 and 5. So then this would also have a 2 in it, and then you got this one out front, and then you got the 5. So see how I get the 2 times 2, that's how you get the answer of 4. So 80 can be a little bit difficult. Probably the better combination would have been 16 and 5, but I'm not sure that many people think of 80 as 16 and 5. So if you're having trouble breaking down the radicals, that's kind of a separate lesson. So you might want to see me and we can work on that individually, but that's kind of the issue there. On number 3, the one thing you have to notice is that they give you the hypotenuse. So you got to be very careful. So you go a squared plus b squared is equal to c squared. So this is going to be x squared plus 25 is equal to 64. Now you're going to have to subtract the 25 instead of adding, because in this one they give you the hypotenuse. So 64 minus 25 is 39. If you try to take the square root of 39, you'll get a decimal. But also, if you look, 39 is only divisible by 3, and then 13 is prime, so there's really nothing you can do. So that's why that one just stays the square root of 39. On the next one, you do again 12 squared plus x squared is equal to 13 squared. So that's 144. I don't know what 13 squared is. 169. Then you would subtract the 144. And so x squared is 25. So if you take the square root, notice the square root of 25 is perfect. So basically on this section, they just don't want decimals. And so, if you can leave it, if it's perfect, then that's great. But otherwise, you'd want to break them down into their radical form. So if you have questions on that section or on the radical portion, please see me. All right. The next one is an application. And if you read it, basically the most difficult part here is it's talking about this safety ratio. So think about, you've got this rectangular frame, okay? And it says he wants the ratio of length to width to be 3 to 1. So length is 3, width is 1. Then it says the diagonal is 12. So now you can kind of see how you're going to have to work your Pythagorean theorem. So we're going to go a squared plus b squared is equal to c squared. So this is 9x squared plus 1x squared is equal to 144. That's going to be 10x squared is equal to 144. So if we divide that off, that's x squared is equal to 14.4, and then take the square root. Now because this is a decimal, we would have to put it back in decimal form, because you couldn't leave it in radical form. So then x would be about 3.79, and it says how wide. Well, that is the width. It's just 1x. So this would be your answer right there, 3.79. So why don't you try number 6? I think the only thing that's really tricky on 6 is to know where the 4 and the 1 go, because it doesn't really tell you. So if you think about a wall, with like a ladder, this would have to be the 4 and this would have to be the 1. Otherwise, it'd be very, very steep. So it's the 1 and the 4. And then your ladder would be the 30, okay? So see if you can go ahead and pause it here and do those calculations. All right, hopefully you've worked those out. This would be 1x squared, and this would be 4x squared, and 30 squared. So that's 1x squared, 16x squared, and 900. Let me just make sure I was taking, yeah. And so this would be 17x squared equals 900. So you're going to divide by 17. So you get 52.94. And then you're going to take the square root. So that means x would be 7.28. And it says, how high will a 30-foot ladder reach when placed against a wall? So it would reach up about 7.28 if you were to go based on this safety ratio. Seems like it should reach a little bit higher, but that's based on the safety ratio, okay? Now, that kind of concludes the basic Pythagorean theorem stuff. Now they get into a little bit more vocab, okay? So the next part you see here actually stems a little bit from 5.3. Remember where they gave you 3 numbers of a triangle? So it kind of relates to, I don't know if I want to say yesterday's lesson, but the 5.3 lesson. It's often called a Pythagorean triple, but what they're basically asking you is if you look at these numbers, can you determine if that's a right triangle? So you say, okay, well, first of all, 9 plus 12 is bigger than 15. So I know it's a triangle. But is it a right triangle? Well, what you do is you test them. So you see if it works. So you're going to go 9 squared plus 12 squared, and you're going to see if that equals 15 squared. So you're just literally going to type in your calculator, 9 squared plus 12 squared, and you're going to compare that to 15 squared. And if you notice, it does equal. So you'd say, yes, this is a right triangle. So that's kind of what they're asking you. But if you notice, like number 8, it is a little bit of a trick. Because what is 7 plus 6? 7 plus 6, I have to think about it for a second. Oh no, it is greater than 12, so it's not a trick. Sorry, I was thinking it was for some reason. So we checked, it is greater than 12, so we're okay. So now what we're going to do is we're going to go 6 squared plus 7 squared and see how that compares to 12 squared. So again, I'm just taking my calculator. And how does that compare to 12 squared? And if you notice, they're not equal. See, this was 85 and this is 144. So because they're not equal, it's not a right triangle. Okay? All right, I apologize. Today has not been the day to record. There's been lots of interruptions, but I do apologize. So, number 9. Number 9, what you'd want to do is, again, you'd want to check the smaller two, but when you add those together, it's bigger than 50, so you're okay. But now we're going to go ahead and go, all right, a squared plus b squared, so it's the two smaller, and compare that to the 50 squared. So if I just type that in my calculator, 48 squared and 14 squared, does that equal 50 squared? And if you notice, just in my calculator here, it does equal, which means yes, it is a right triangle. Now, the last part is, well, what if it's not a right triangle? So when you look at this one, say 5 squared, 7 squared, so if you type those in, 5 squared, 7 squared, compared to 10 squared, you know that those aren't equal. So you can kind of see there, they're not equal. I get 74 and 100. So it's not equal. So I have a 74 compared to 100. But is there another way to classify it? So it's not right, but is it something else? And the answer is yes. If the c squared is bigger, so basically what you're looking at is if you have a triangle where here's your small, your second, and your c squared is the biggest. So if the c squared is the biggest, notice what kind of angle that's going to look like, which means it will be obtuse. If the c squared is smaller, so let's say you have your a, and there's your b. Sorry, your a, your b, and let's say there's your c now. The c is still going to be the longest, but look at the angle, okay? So if the c squared, not just c, but c squared is smaller than the other two squared added together, then this is going to be acute. So when I go back up to this one, do you see how the c squared is bigger? So if the c squared is bigger, then that means this is obtuse. So now again, you just test them. So you're going to go, all right, 7 squared and 12 squared, and compare that to 16 squared. So you type them in your calculator and compare that to 16 squared. And what I'm noticing is the 16 squared is also bigger. So if the 16 squared is bigger, then that means this is obtuse. So why don't you pause it here and try numbers 11 and 12. All right, hopefully you've tried it. Number 11 is actually a little bit of a trick because if you add these together, you only get 13, which is not bigger. So this is actually not even a triangle. So that's a little trick. But if you go to 12 and you tried this one, 8 squared and 11 squared, and if you compare that to 13 squared, you get 185 to 169, which if you notice the c squared is smaller, so it's like smaller, which means this is acute. So you have to kind of remember, if the c squared is bigger, then it's obtuse. If c squared is smaller, then it's acute. And if they're equal, that's when it's right, or Pythagorean triple as it's often called. So that ends lesson 5-4.